Welcome back to Young Engineers of Today. We're moving on from HTML. We're going to move on to Inkscape. And some of you have done Inkscape before, I know, for that. Sorry, there's going to be some stuff, a lot of stuff that we're going over that's going to be repeat, and you're going to be like, oh God, when will it end? We'll go over we'll have a project at the end to do. Some of you never seen Inkscape before, so this will be all new. So we'll spend some time introducing vector graphics, why we use them, things like that. Then we'll go over actually installing Inkscape, because I know we had you download Inkscape at the beginning, but we never necessarily went over the installation process. On top of that, there might have been some of you who weren't here in the first class, so no judgment or anything like that, just you may not have been able to make it, in which case we'll have you download Inkscape today so that you'll be ready to go for Wednesday. At any rate, oh, you have a new computer, so you need to download again? Gotcha. Well, congratulations on the new computer. We're gonna hold off on actually using Inkscape today, just for that reason. I know not everybody's gonna have it up and running yet, so we'll spend Wednesday actually messing around with Inkscape, at the very least. Getting it up and running for everybody. At any rate, Inkscape. Well, what is it? It is a software program that allows you to draw and edit vector graphics. It's free and open source, and for that reason, it's a pretty viable alternative to software such as Adobe Illustrator, which is also a vector graphics editing program. You might notice a theme that runs throughout the semester, and that is we'll use free and open source software as often as we can. Makes our lives easier, makes your life easier. Plus, open source stuff is pretty cool. The whole idea that people just out there are making tools that you can use, that maybe they're asking for a donation, but that's it. And you have the ability to modify the software as well to your need and redistribute it freely as a free software. Things like that. That's sort of the really nice thing about the internet and about computers nowadays, is the ability to collaborate like that on such a massive and worldwide scale. At any rate, I said that whole thing, how it's a software program that allows you to draw and edit vector graphics, but that may not mean anything to you. Like, what exactly are vector graphics? Why would you care about it? Why do they have such a fancy name? Well, let me tell you. Vector graphics, this is going to be weird. Vector graphics are the representation of images based on mathematical expressions. That is literally what vector graphics are. These graphics are based on vectors known as paths, which lead through locations known as points or nodes. I'm going to spend a little bit more time explaining that so it'll make more sense. Because right now, I mean, maybe you can sort of think of it, but that's sort of the more technical definition, I guess. I guess the most technical definition would be vector graphics are graphics created with vectors. But that's a circular definition. Vector from Despicable Me, yeah. So you have two different types, basically two different types of graphics. You have vector graphics and you have raster graphics. And they are quite different from one another. How many of you are familiar with pixel art? I know it's sort of a softball question. I should expect to see quite a few hands. Okay. So if you're not, when I say pixel art, I mean pictures from like NES games and stuff like that, where the dudes are made up of basically colored dots. That's pixel art. And the reason it's called pixel art, if we want to get into this, is because each pixel matters. That gets more into the argument as to what is and is not pixel art, and that's another argument for another time. But basically, the thing is you place down individual squares in order to make up a picture. That's really the point I'm getting at. A lot of stuff, we'll go over how to download Inkscape and stuff like that at the end of this lesson today. What do you mean, Liam? We went over HTML over the last couple of weeks. We just started going over Inkscape. Oh, no. No, we literally just got started. Yeah, no, you're fine. No, so anyway, you place down color blocks individually in order to create an image. That is an example of a raster image. I know I'm not explaining this terribly well, so let me turn to Paint for my incredible visual illustrations. A lot of the images you deal with on the internet are going to be raster images. The reason they're called raster images is because they are. I actually, unsure on the definition of raster, but essentially what they are is they're just a grid of individual pixels. Here's me drawing my grid. Ooh, look at that grid. I put way too many squares in this grid. And some of these squares in the grid might be colored in. And that's how you get your picture, is by coloring in these squares with various colors. Let's pretend that this is actually something that makes sense. Like this is a picture of a turret, I guess. I don't know. Or a 6, yeah, or it's a 6 or an S or something like that. Let's look at the red then, yeah. So it's kind of like a 6. Let's make this, oops, oh no. Or a dead checkerboard, yeah, that too. But like you sort of glean the form of the picture by looking at how all of the different squares are arranged, right? So like you say, it looks kind of like a 6 or an S, and that's because you're looking at all the red squares and making a pattern in it out of your brain, or from your brain. Like your brain is making a pattern out of it. That is the whole idea behind raster images. It's a grid of pixels that are all differently colored pixels, and the whole makes up a picture. This is, in fact, what I just made. Paint is a raster image editing program. So if we were to zoom way in, you could see individual pixels. You can see them right here. Here's like a gray pixel, and here's a slightly darker gray pixel, and then a lighter gray pixel, and then we got a bunch of black pixels, and like sort of a pretty dark gray pixel, and you know, isn't everything made out of pixels? Yeah, no, that's the thing. Okay, yes, everything on the screen is technically projected out of pixels, but it's how the image is rendered and processed. So when I say it's an image that's made up of a grid of pixels, the pixels are the components of the picture. That offended me. So the pixels are what? How am I trying to say this? Okay, we could take a raster image and using a little bit of computer wizardry, we could look at it in a plain text file. If we were to look at it in a plain text file, let's imagine that each color has a number represented with it. For instance, black is going to be 0 and red is going to be 1. We're just going to use that as a very, simple example. If we were to look at it in a plain text editor, it would look something like this, where the 1s represent red and the 0s represent black. And it's just a grid of numbers, and the computer will interpret that grid of numbers into individual colors to form an entire picture. That's the basis of a raster image. Now, a vector image, on the other hand, how many of you have gone through algebra and done graphing in algebra or pre-algebra? Okay, so we got a few hands. I got a me from the question box. So you know the whole like y equals 2x plus 1, and how we create a graph and it would look something Yeah, y equals mx plus b form. Yeah, exactly. But it would look something like this. Like we would create a line from a mathematical equation, right? Well, here's the thing. Using other math uh, concepts and stuff like that, we can create super ridiculous, crazy lines. We can create lines that look like this. We can create lines that look like this. We can create lines that look like this. We can create lines that look like that. We can create lines that are circles. We can create lines that are, just all kinds of different stuff. So we have a lot of freedom when it comes to representing lines with mathematical equations. You see where I'm going with this? Okay, some of you do. All right, excellent. So let's continue with this idea. So we have a whole bunch of lines that you can create with mathematical equations, right? Now, what if we were to say, okay, I want to draw, let's say I want to draw, let's start really simple, just like a really stupid looking boot. Now let's take our imaginary graph. How would we draw a boot on a graph? Okay, let's see here. Let's say we have some points, right? Let's say we have points that look like this. It looks kind of like a boot, right? Sort of, like if we were to do a connect the dots with our, imagination. Okay, give me the benefit of the doubt here. Now, let's throw in some numbers. That's supposed to be a -1. And this is a 1, and this is a 2. So now, let's see here. How would we draw the line y equals 2? And you can just say like, a slanted line, a curvy line, a straight line. You don't have to like actually give me a detailed description of the line. Yeah, a straight line. A straight horizontal line, right? Yeah. Look where our two dots are right here. They're at y equals 2. So if we were just to draw a straight horizontal line there, let's say we had another one at y equals -1. Look at that, another straight horizontal line. Now let's say we had one that was at x equals -1. That would be a vertical line, a straight vertical line. Yeah, because x is 0 and that's the slope. Here, the slope for x is infinity. Let's say we had another one where x equals 0.5 or 1/2. We got another straight vertical line right here. And then let's say this one is like y equals x to some power a with some coefficient in front of it, b plus, I don't know, c or something like that. And that gives you some line that looks like this. Put them all together, and what do you have? You have this janky looking boot that I drew. And you've represented all of the parts of that boot with mathematical equations. That's what vector images are. Vector images are images represented with mathematical equations. So if you'll remember, if we took our text file of a raster image, we would have like a whole grid of numbers like so, blah, blah, blah. If we took a text file of our vector image, we would be looking at like 0.2 from blah, 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 blah. And y equals -1 from blah, 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 to blah, blah, blah. And, x equals 0.5, so on and so forth. So you would have just like a listing of mathematical equations, and then the computer could interpret those, graph them out, and you would have a drawing. It's like how people, there was this image that floated around the internet for a while where somebody created the Batman image with just mathematical equations. Just a series of mathematical equations that you graphed out, and suddenly, bam, you had the Batman symbol. That's the basis of vector images. So whereas, yes, everything is made up of pixels because your screen is comprised of pixels which then project the image to you, this is what I mean when I say the difference between raster and vector images is raster images focuses on the individual pixels, and vector images are more concerned with the equations that represent that drawing. So it's kind of weird, right? Like it's weird that we would have an image style that depends on being represented with mathematical equations. Now, we drew a really simple boot, right? But what if we wanted like, you know, a more complex boot? What if we wanted to draw something that had like this up here and, you know, it had like boom and it had the laces and the laces ran all the way down and there was a heel on the boot, you know, like this, and like maybe there were some like wrinkles and stuff like that in the boots, and there was a tongue that ran up it. And you know, there was detail to it, you know? So how does something like that get represented with equations? Because I'm pretty sure there isn't an equation that looks like this or even looks like this. That the idea being that those are two separate equations. Well, simply, all you would need to do is you would need to increase basically the number of nodes. So you know how I created those dots for the connect the dot? Yeah, you'd increase the number of equations that you use to represent it, and each equation would represent a smaller part of the drawing. So instead of this, instead of our connect the dots looking something like so, we might have our connect the dots look something like we might have like a lot of dots, you know? In which case, so you might have like tons of dots. In which case, you know, your vector image is going to be more complex, but you do have the ability to create better and more detailed looking images with more complex vector graphics images. Now, those dots are referred to as nodes. And then the lines are known as paths. So vectors are combinations of nodes and paths, dots and lines. That's really all they are. They have all these fancy terminology names for them, and that's just really all they are. So let's see here. Other image files like JPEGs, GIFs, and bitmaps are made up of a grid of pixels. These are often referred to as raster formats. Vector graphics are comprised of paths defined by a start and end point, along with other points, curves, and angles along the way. That is, I mean, that's what I just explained. That's what vector graphics are versus raster graphics. Now, here's the thing. With vector graphics, you can layer different drawings on top of one another. Why would that be useful? Well, it helps. It's another way that you can create more complex images. This little tiger cub here is a vector image. How do you make vector images? With vector image creation programs, honestly. I mean, you know, you can try and make a vector image manually by graphing it all out, but you'll just tear your own hair out. So we use stuff like Inkscape, which you just draw it like you would a regular picture almost, and it will do all the hard work in the background and represent it with mathematical equations that can then be used with other, vector image editors. That's really the easiest answer there. As far as writing something like that is concerned, hey, no worries, Andrew. It's all good. As far as writing a vector image is like something that could create a vector image, as far as writing a vector image editor is concerned, that would involve writing a program that can graph equations, that can group them by layers, can color in groups with different colors, and can take a graph and turn it into an equation. And for that last one, basically all that means is the user would draw something and then the computer would interpret it as an equation, figure out the best fit equation for it, and basically store that in the file so that it can be used later on. So no, you don't manually make the equations, thankfully. No, that's just the concept behind vector images. Somebody else has already done a lot of the hard work for us. Computers do a lot of the heavy lifting for us. So all we do is we just draw them, and then the computer does all the interpretation for us. So now, another way you can create more complex vector images is by layering primitives. All primitives they're just simple shapes. Just really, really super simple shapes. So again, back to our boot example, let's say instead of having like a million dots, you had a few different primitives. You might have a primitive layer that looks like the whole boot outline. And you might have a primitive layer that looks like the top of the boot filled in. And you might have another primitive layer that looks like the laces. And you might have another primitive layer that looks like the bottom of the boot. And you might have another one, etc. You get the idea. And then all you would simply do, whoops, let's just do this. We'll select it like so. And if we layered it, assume that I, actually drew it properly. It kind of looks like that hole is included. Likewise, if we layered this on top, boom, now the boot has laces. And if we layered this, now the boot has a sole. Excuse my absolutely terrible representation, but you get the idea behind where I'm going with this. So you can layer the stuff on top in order to make it a more complex image. As you can see in the example here, here's the tiger cub's nose. The tiger cub's nose is a layer of fur. Looked kind of like an ice skate. It did look like an ice skate. They have another layer which is basically the detail on the fur, like all the dark parts and stuff like that. They have another layer which is actually the pink nose itself. And then a final layer which is kind of like the outline / shadowing on the nose. All of those things combined, as you can see, create the actual nose of the tiger cub. So it looks, or lion cub, or whatever this is. So it looks like a much more complex image. So, this is cool and all, but why? Why would you spend time creating a whole new image format that is based on graphing? Why? That just seems like a huge waste of everyone's time involved. But why though? Why? I mean, raster images, right? I mean, math is cool, and I think that's a totally valid reason just to do it for its own sake, but let me show you a thing. So like I zoom way out on this, right? Look how sharp that picture looks. I zoom way in on this, I want to blow it up. And suddenly it looks super duper ugly, like we have all these jagged lines and like the lighter pixels and stuff like that, which act as kind of like dithering or shading, sort of to make the edges look less sharp at a distance. So, you know, now it looks all like jaggy and things like that, and it really doesn't look nice. So let's say this boot was something that we wanted to blow up to a larger size. Well, we wouldn't be able to, because the minute that we zoomed in on it, people would be like, ew, oh, no, no, that's terrible, it's horrible looking, I don't want to see that, oh gosh. And we run into an issue here. However, cool thing about vector images and math in general is this stuff is scalable, right? Y equals X, just that simple horizontal line, we can extrapolate what it's going to look like on a graph out to forever in either direction. Let's say we wanted to make a line of y equals x just be like boop, that long. We could. Now let's say we wanted it to be that long. We could, because we have an idea of the size and shape of that line. And we don't lose any information. Because that's the thing that happens here, is no new information is gained. So the information we have is just magnified. It's like a digital zoom on a camera, and it's just going to look uglier. But here's the thing. With vector graphics, because they are expressed using mathematical equations, we can magnify them. We can resize them. We can make them smaller. We can make them larger, and we're not going to lose any quality. The image is going to look just as sharp, magnified 7 times, as it is at original size. It's going to look just as sharp, magnified 1,000,000 times as it is original size. We could create a vector image on our computer that's like, you know, like, let me draw this tiny little icon right here. It's like, woo, woo. Like, that's whatever. That's our company logo or whatever. And then we could blow it up to be the size of a billboard, and it will be just that sharp and ugly because I drew a really ugly thing. But, like, we won't get this really crazy jagged edge business going on that I've got going on here. Like, it will look like that all the way up forever, essentially. So like this, we can make this ginormous. We could make this large enough to put onto the size of onto the side of a building, and it would be just as sharp as the original size we created. Their edges will stay smooth and clean since they aren't a specific number of dots, but instead a series of defined and related curves. That is one advantage of vector images. Now, I bet you weren't just expecting me to say just one. There are other advantages to vector images. Well, because vector images, they can be very memory intensive to have very complex vector images. They can have unnecessary amounts of information in them. They can be, basically there are advantages and disadvantages to both. If you have an image that you're planning on keeping the same size, a raster image is a very reliable means of doing that, of conveying it. A raster image is easier to basically create like an image viewer for. All you have to do is just interpret the different numbers to different colors and stuff like that, right? So, you know, when you're creating something that uses images, it's going to be far easier for you to deal with a raster image viewer rather than a vector image viewer. For larger images, well, for more complex images, raster images are going to be smaller. than vector images. Stuff like that. Here's another thing you can do with vector images, though, vector graphics. You can take those nodes and move them around. You can wiggle them around. And then when you wiggle them around, oh, that's not gonna, okay. When you wiggle the nodes around, let's make this larger, the vector image will update and basically regraph those lines so that you can distort the image. How many of you have heard of a thing called tweening? It's an animation style. Yeah, it doesn't really seem like many people have. No, that's fine, that's fine. Okay, so here's the deal. You know how vector images are made up of cells and layers and groups and stuff like that? Well, you can turn those groups into, like, you can make individual parts of a drawing be grouped. So let's say we have our dude here. Well, if these are all individual groups, I can like move the arm, and it's easy. All it has to do is just update the equations that everything is connected to, that all this stuff is connected to, and we are able to basically move that around as much as we'd like in real time without having to like do all kinds of redrawing and stuff like that. With like a raster image, we would have to update all the individual pixels. With a vector image, all we do is we just update the position of the nodes, and if there's any rotation involved, we update the graphs, the equations, so that they still point to those nodes. We can take it a step further too, and we can add slight animation to it. So like we can make it so that maybe there's a hand with some fingers on the end. We can make one of the fingers extend. Let's draw all the fingers. Or like the thumb bends or whatever. And we can change the shape of the vector image basically much more easily than we can with a raster image. Tweening is taking those individual groups and moving them around in order to create animation. So if you've ever seen like an animation where there's like a drawing of a person or something like that, and the individual parts aren't actually like animated, but they move around, that's tweening. Well, sort of. Tweening is also the interpolation between those movements and between different images and stuff like that, but that's beyond the scope of what we're talking about here. So that's something else you can do with vector images. You can update them, change their shape and stuff like that much more easily than you can with raster images. And for that reason, they're a very popular means of animating for people, because it doesn't have to rely on redrawing each frame like you would with a raster image, or at least copy pasting huge parts of the frame and then drawing the different parts and stuff like that. So that's basically, those are basically like the major strengths of vector images. They can be smaller than raster images. Like if you have a large simple picture, like it's just like a circle and a triangle or something like that, a vector image is going to be a much smaller file size than a raster image, because a raster image is going to contain information for all of those pixels on that gigantic drawing. It's just going to have to keep track of all of those pixels, whereas with a vector image, it's just going to have to keep track of the location of important parts of that picture, as well as the equations for the lines that complete the drawing. However, if you're going to have like a big complex cityscape picture or something like that, you're definitely going to want to go with a raster image, because the amount of nodes that you're going to have, like if you have this, let's find an example here. let's say something like this. This is going to be insane to draw with a vector image editor. Because look at all the detail that exists on this. In fact, this is a JPEG. This is a raster image. Look at all the detail that's on this. Like, you've got all the individual parts of the buildings. You've got all the lights from all the stuff in the background. I don't know. Off the top of my head, I couldn't tell you. But it's just, it would be ridiculous to try and create a vector image off of this, because you would have to create basically a node for every single point of interest. So, like, let's just look at this building, for example. I'm going to zoom in on this, and it's going to look ugly, because again, it's a raster image. But look at that grid design. And even inside of the grid design, whoops. Even inside of the grid design, you have stuff like different levels of light and things like that. And the vector image would have to take those into account. It would have to create like nodes here and 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 here, and then do like a graph that represented that area, and then keep track of its color, and then do nodes for here and 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 here, and then that's just for that part of the picture, just right up here. Just that little tiny part of the picture right up there. It would have to do it for everything here, which computers are good at what they do, but that's too much. That's too much. And then there would be, you'd probably get some details that are lost, like you wouldn't get the ripples in the water and things like that, because a vector, it'd just be too much for a vector image to do. Can you imagine this little area right here? That would turn into a mess. Or all of this down here would all get lost. Like, it's too much. So for that reason, a raster image does fantastically, because at the proper resolution, it can convey all of that information just simply by having the correctly colored pixels at the right spots. And I believe this is, I don't know where this is. Might be China? I don't think it's China, though. It might be China. No, it's not China. What am I thinking? I should mention that I fail horribly at recognizing cityscapes. Well, I'm looking at these names over here, like Conrad and Swire, whatever. It's Westminster. It's London. We're looking at London. Well, there's Bank of America over here too. What? There might be a Bank of America based out of London, because yeah, this might not be Bank of America London edition. Well, actually, London will probably remain to be for another like couple of years a huge banking mecca. Huge. Huh. Interesting. Swire also does bottling in Hong Kong. London is very small. No, it's Hong Kong. It's Hong Kong. My initial impression was right. It's Hong Kong. It is China. Bank of America has a headquarters in Hong Kong. Conrad is a hotel in Hong Kong. Swire has a bottling group in Hong Kong. A little bit of internet sleuthing. Yeah, this is totally Hong Kong. Yeah, well, I mean, English is a very popular international business language. So a lot of non-English speaking companies will also include English. Where? Oh, you mean this over here? Anyway, a lot of non-English speaking companies will include English in their on their buildings and stuff like that. But yeah, welcome to Hong Kong. Oh, this one over here. This is a dragon. This is kind of what I thought was in China in the first place. Also, it's very reminiscent of a lot of like Asian metropolis designs. But yeah, it's a very Asian-looking dragon. Anyway, yeah, this a picture of Hong Kong, totally terrible for a vector image editor. It's totally terrible for vector images in general. Can you imagine how many equations would have to make up this image? How many equations would have to make up this image in order for it to be a faithful recreation? At least. I think I think you're undershooting it by a couple powers of 10 by saying a couple million. It could be. It could very well be a couple billion different equations. I mean, maybe I'm overshooting it, but I'm just looking at like details like this. I can't go anymore. The little GoToWebinar window's in the way. Like the top of this building over here and all of its different windows, stuff like that. Like that would be a lot of work as well. Anyway, let's spend a few minutes going over downloading Inkscape for those of you who do not have it yet so that you can get it on your computer. It might be. Well, no, probably not. I don't think it's quite in 4K. Its resolution is... No, it is in 4K. 3840 by 2560. Yep, 4,000 pixels along one side. I don't have a 4K monitor, unfortunately. So there's... Like, I look at it and I go, ooh, big picture, pretty, but it doesn't mean anything to me. Anyway, because I don't have enough pixels. So, let me pull up the download link. 4K refers to the resolution. So when we say this is 3840 by 2560, it's 3,840 pixels along one side and then 2,560 along another. And a lot of times it's what 4K refers to because it's a lot catchier to say 4K than it is 3840. But it does refer to like the number of pixels. So like when we were saying, when HD was first coming out, a lot of people were like, oh, is it 720 HD or is it 1080 HD? You know, and like TVs and stuff like that, whereas computers have been able to do that kind of resolution since forever before TVs. 1440 HD refers to 1440 pixels along the long ends, whereas 720 HD is 720 pixels along the long end. And then P and I, it's like interlaced and per frame and stuff like that, and blah. That's all another thing. Anyway, here is the link for the Inkscape download page. Let me find the chat box so I can put it into the chat box. Well, bam, it's in the chat box. So what I want you to do is I want you to click on the picture of your operating system. As you can see, you've got Linux, Windows, and Mac. And it'll just take you to like right here. If you're on Windows, it'll ask whether or not you want 32-bit or 64-bit. If you just got a new computer, you're going to have 64-bit. If you're not sure, chances are you have 64-bit. If you have a very old computer, not very old, but a decently old computer, there's a possibility that you're running 32-bit. So if you're unsure, just go ahead and throw it into the question box, and we can ask a couple of questions and probably divine what version you have. Windows 8.1, probably 64-bit. 98? Yeah, you would click on the installer. Yeah, you would definitely install it. If you're running Windows 98, you would definitely be 32-bit. Chances are you wouldn't be able to run this, though. 64-bit, definitely, Carson. Windows 3.1? Oh my gosh, how are you running this software? Yeah, generally. I don't know if they actually furnish a 32-bit installer for Windows 10. I see. You're saying you're not actually running Windows 3.1. Windows 7 is like right on the cusp there, more so than Windows 8 is. Windows 8.1 is a pretty safe bet that you're running 64-bit. Windows 7 could really go either way. I would say to be safe, you download the 32-bit because it will still run on a 64-bit computer. Whereas the other way around is not true. You cannot run a 64-bit program on a 32-bit computer. If you have more than, I believe, it's anywhere from 4 to 8 gigs of RAM. Oh, you already have 64 from last year? All right, excellent. Yeah, we're gonna have this be the last thing we're doing in the class. But yeah, if you have, I believe it's more than 8 gigs of RAM, you're gonna have a 64-bit. It might be 4 gigs. Anyway, that's the whole reason why they have 64-bit and 32-bit and stuff like that. That refers to the size of the instruction that the CPU can take. If you've already downloaded and installed it, then yeah, you can head out. If you have any other questions, you're more than welcome to ask me. But when it's done downloading, go ahead and install it. If it's already done installing, and you're running like a Windows operating system, you're fine. You're good to go. Yeah, let's do the poll questions. I'll go ahead and